right. And I'll just go ahead and rewrite that. Okay, so in this case, we'll let our u equal e to the 2x. Which means our du is going to equal 2e to the 2x. Remember, e to the u times du dx with respect to x. Which means our e to the 2x with respect to x is going to equal du over 2. Alright, so we go ahead and plug that in. From 0 to 0.1, secant squared e to the 2x times e to the 2x with respect to x. Alright, so that gives us our secant squared of u. And our e to the 2x dx gives us our du over 2. Right, and then we just go ahead and plug it in. So the integral from 0 to 0.1, secant squared u du over 2. We can just go ahead and bring our 1/2 right out to the front. Okay, so that means we now have our 1/2. Integral of secant squared is tangent, so 1/2 tangent of u. We don't need the plus c because it's definite. From 0, remember this is x equals 0 to x equals 0.1. Okay, now if you want it, you can convert that to u, but it's a lot of extra work. So if you just plug that back and make it an integral with respect to x, you don't have to convert anything. So you have 1/2 tangent of e to the 2x from 0 to 1. Okay, so that means you're going to end up with 1/2 tangent of e to the 0.1. I forgot something. To the 0.1 minus tangent of e to the 0. So you end up with some tangent of e, tangent of e to the 0.2 minus tangent of e to the 0 is just tangent of 1. And plug that into your calculator, you get some, you can either leave it like that or you plug it in, you get some value of 0.594, give or take. Alright, so any questions on that one? Some of them. It gets a little bit harder. But these are the easy side of the scale. All right, so so here we're going to integrate where either sine or cosine has at least one odd exponent. And this is where you're integrating them together. You're multiplying, integrating the product of sine and cosine raised to some power. Okay, so at least one of them will be odd. So let's say you're integrating sine of 2k plus 1 with respect to x, and cosine of some power n with respect to x, where this represents your odd exponent. Okay. So you're going to make sine of, let's say, 2k plus 1 of x equals, let's say, sine squared of x. K plus 1. Oop, did I get that one wrong? Oop, did I get that one? Yep, 2k. Yep, there it is. Sine of x. Okay, so remember, you have your sine 2k plus 1. So all you did was just kind of factor a sine out of there. So if you had sine to the 5th, you'll make it sine to the 4th times sine. If you had sine to the 49th, you'll make it sine to the 48th times sine. So you just factor one of the sines out of there. Okay, so that means now you have the integral of, let's say, sine with the to the m power. Can't use n again. We already used that. Of x. And cosine of 2k plus 1 with respect to x. Okay. In that case, you'll make cosine of 2k. Why do I keep putting x? 2k plus 1 equal cosine squared of k plus cosine of x. Oh, cosine squared of x. Oh, cosine of x, sorry about that. Okay. Now in these cases, we have them squared. You're going to make the sine squared of x to the power of k. Oh. Remember, sine squared, and let me write that here because I'm pretty sure it's one of those things that's been forgotten. Sine squared of x is equal to 1 minus cosine of 2x over 2. Cosine 2x, or squared x, is equal to 1 plus cosine of 2x over 2. Okay. You're going to make that 1 minus cosine of 2x over 2 to the power of k. Nope, should have separated that. When sine is raised to an even exponent. Okay, so these are when you have at least one odd. You're going to factor one out of there. Okay, you're also, when you have even ones, and I'll work this out in the example. So you're going to make cosine of square root of x, okay, into 1 plus cosine of 2x over 2 to the power of k, when cosine is raised to an even exponent. Okay, and we'll do examples of all four of them. So hopefully you'll see what I'm talking about. Anyone still writing? All right. Oh, sure. Mm-hmm. All right, so let's say, for example, if we wanted to evaluate the integral of sine 2x cosine to the fourth with respect to x. All right, so for this one, you want to remember that cosine 4 of 2x is the same as saying cosine of 2x to the fourth power. Okay, and we also want to remember that the derivative with respect to x, cosine of u, is negative sine of u. Right. All right, so let's say if we have our sine of 2x and cosine of 2x to the fourth with respect to x. So I just kind of rewrote it a little bit. Okay. So in this one, you don't have to really worry about it because you only have sine to the 2x raised to the first power. But what if we let u equals cosine of 2x? Okay, so we have our u. Means our du is going to equal negative sine of 2x times 2. With respect to x. So if we divide both sides by 2, or negative 2, you have sine of 2x dx equals du over negative 2. All right, so now if we just go ahead and rewrite it, you have the integral, might as well flip that over. cosine of 2x to the 4th power sine of 2x with respect to x, which is our original integral, but we kind of flipped it around. Okay, so we have the integral. Remember, that's our u to the 4th. And that's our du over negative 2. All right, so we get our negative 2, just bring it right on out to the front. So that's negative 1/2 integral of u to the 4th du. Okay, which is just, once you integrate u to the 4th, is u to the 5th over 5. So negative 1/2 is 1/5 u to the 5th, plus c. Right, go ahead and distribute the 1/2 and plug in our u. We have negative 1/10 and our u, which is cosine of 2x. So cosine of 2x plus c. All right. So when it's just to the 1st power, you don't really have to worry about factoring out anything because it's just the 1st power. All right. So any questions on that one? All right. We did that one already. Everyone's still writing. Oh, okay. Excuse me. Okay, so let's say, for example, we wanted to evaluate the integral of cosine squared x, sine to the 3rd x with respect to x. All right. Now with this one, by sine being raised to the 3rd power, you will have to kind of factor out 1. Because if you actually tried to use the u substitution there, it wouldn't work. Okay, so sine cubed to the x, you're going to make that sine squared of x times sine of x. Okay, so remember, sine squared of x is equal to 1 minus cosine squared of x. Okay, so this is just going to be 1 minus cosine squared of x times sine of x. Okay, trust me, it all works out. All right, so that means we have cosine squared of x, and instead of sine 3 of x, we're going to make that 1 minus cosine squared of x times sine of x with respect to x. Okay. And the reason we need that x in there is because that's going to be our du. So we're going to need a sine of x out there for that du to work. Okay. So if we let u equal cosine of x, so our du is going to equal negative sine of x with respect to x, which means our negative sine of x dx, or positive sine of x dx rather, is going to equal du over negative 1. or negative du, whichever way you're comfortable writing it. All right, so if we go back to our original one, let's just go ahead and rewrite that. The integral of cosine squared of x times 1 minus cosine squared of x sine of x with respect to x. We can just substitute it from there. Okay. So cosine squared of x, that's just u squared, times 1 minus cosine squared of x, times sine of x dx. Remember, that's our negative du, or du over 1, or du over negative 1. And put that right around there. So we can go ahead and just factor our negative 1 out to the front. And if you wanted to, in this step, you could just go ahead and distribute that u squared. Okay, so you have u squared, or the integral of u squared, minus u to the 4th with respect to u. Okay, so that's really a whole lot easier to integrate than all the sines and cosines blasting around there. Okay, so if we integrate that, don't forget your negative. 1/3 u to the 3rd minus 1/5 u to the 5th. Oh, got my plus c. And if we distribute that negative, it pretty much just switches those around. So you have 1/5 u to the 5th minus 1/3 u to the 3rd plus c. So now that we have it all simplified, we just go ahead and plug it right back in with our u. So our u is cosine of x. So that gives us 1/5 cosine to the 5th x minus 1/3 cosine to the 3rd x plus c as your final answer. Okay. Oh, straighten that up some. Any questions on that one?
Will it matter that it's in descending exponent order?
Which one? Which part are you looking at?
Because it.
Oh, you mean
yeah.
this? Oh no, it doesn't matter. Yeah, if you want to leave it as negative 1/3, then 1/5, that'd be okay. That's just me having my own little mental order that I want it in. So other than that, it'd be okay if it was the other way. All right. Any other questions on this one? All right. Let's see if I have another one here. Nope, anyone's still writing. Nope. I'll wait till you finish up. All right. Okay, so let's say if we wanted to evaluate the integral, say cosine to the 5th sine squared of x with respect to x. Okay, so since cosine to the 5th is your odd one, cosine to the 5th of x, we're going to make that cosine to the 4th of x times cosine of x. Okay, so if you remember, cosine squared of x is equal to 1 minus sine squared of x. Okay, so this, we're going to rewrite it as cosine of x squared, well, cosine squared of x squared times cosine of x. Okay. Which means that your cosine to the 5th of x is going to equal 1 minus sine squared times cosine of x. All right. Okay. So we're just going to rewrite that. It's cosine. Oh, forgot I already. One minus sine squared of x squared times cosine of x times sine squared of x with respect to x. All right. So for this one, we're going to let u equal sine of x. Okay, which means our du is going to be negative cosine of x with respect to x, or our cosine of x dx is going to equal negative du. Right. So now we can just go ahead and start replacing cosines and sines. Okay. So this becomes the integral of 1 minus sine squared, remember that's your u, so 1 minus u squared times cosine of x. Well, actually we can switch those around, because if we just have sine squared of x, have that times u squared, because our cosine dx is our negative du. Okay. So right now we just have a bunch of u's that we can easily just factor and make those a nice, neat little function. Okay, so if we distribute those u's, and we can take that negative right out front. So we have negative integral of u squared minus u to the, oh, can't do that yet, we got a square there, forgot about that. So that becomes 1 minus 2u to the 4th, no, 2u squared times u to the, plus u to the 4th.
Should it be a negative?
Yeah, it's not negative out front. The derivative of sine is just cosine, not negative cosine.
Oh, I'm thinking integral, sorry about that. Oh. Minus 2u squared plus u to the 4th, and times u squared with respect to u. Okay, so all we did was bring that out, FOIL it, and that's what we ended up with. Now we can distribute our u squared. Okay, so we end up with the integral of u squared minus 2u to the 4th plus u to the 6th with respect to u. All right, and now we just integrate each one. Okay, so you have 1/3 u to the 3rd minus 2/5